Now children, I came to a very important part in chemistry. That is your mole concept. It's very, very important. It's very important. Many of the children, they have a doubt in the mole concept. So please listen from the beginning very carefully and pay attention to it and make a note of it thoroughly. So first of all, what is a mole? I'll not go to the definition. I have already given the definition in your notes. Here also you can say I have written a particular definition. I am coming to again the concept first. You understand, always understand the concept. Definition, formula, you can understand it. You can learn it and you can understand it. But you need to understand the concept first. So what is a mole? If somebody is asking me, what is a mole, sir? Mole, I will say to him, it is a chemist unit of counting particles. Chemist, you know who are chemist? The person who study chemistry. Alright? Who is a master of chemistry, we can say. They are said to be as chemist. So mole is a chemist's unit of counting particles. Particles means? Particles means not that pathar and conquered. Understood? That's not particles here. Here the particles means atoms, molecules, ions, electrons, protons, etc. They are said to be as. Again I repeat, if you ask me what is a mole, I will say to you in simple words, mole is a chemist unit of counting particles. Particles here are atoms, molecules, ions, electrons, protons, etc. They are known as the particles. Now the next question you may ask, what is the need necessary to count these particles? Why should I do so? Fine. Let me ask you again a question here. For example, when you go to a market, you buy some, let us say you are going to buy some rice. How do you buy it? What is a unit? Sir, I buy it in kg, I buy it in grams. Okay, you buy it in kg or grams. Remember that. Clear? Now you want to buy some egg. Then how do you buy it? In kg or in gram? No, we buy it in dozens. Correct? Now suppose you want to buy some oil. Alright, suppose you want to buy mustard oil, or you are going to a petrol pump and you are want to put oil in your vehicle. In what way you measure it? Kg? Dozen? No, liter. You measure in liter. Fine, correct. We measure it in liter. Oil we measure in liter. Fine. Now you want to buy some pencils or some pen. How do you buy it? Liter? Gram? Dozen? No, we buy it in score. Score means what? Unit. One score is 20 unit. You read in the lower classes. So in this way, what we find is that in our day-to-day life, we have got different units for different measurements. Different units. And all are independent of each other. Independent. They do not depend upon one another. To buy eggs, do you need to know the unit of oil? Or is there a relationship between oil and egg? Or is there any relationship between egg and pen or pencil? Is there a relationship between pencil and rice? No, nothing. All are independent of each other. Nothing. There is no relationship at all in your day-to-day life. It is not required also. If suppose somebody is want to put petrol in his vehicle, should he know that what is the unit of egg in which unit he is buying, or rice in which unit he is buying, or pencil in which unit he is buying? Not necessary. Not at all. There is no relationship in our day-to-day life. So hence these units are independent. We buy it independently. We see it independently. But in chemistry lab, got it? Atoms, molecules, ions, got it? Electrons, all these are not independent. They are dependent upon one another. You say how? How it is dependent upon one another? For example, I am giving you an equation. You write down. Take out a pen and copy and write. Zinc plus sulfuric acid. Zn plus H2SO4. What it will give you? ZnSO4 plus H2. Isn't it? It will give you hydrogen gas. Now I am asking you, you do one thing. I am giving you 5 gram of zinc. Tell me the amount of hydrogen gas produced in liters. What did I ask you? I asked you that I gave you 5 gram of zinc. You tell me how much hydrogen gas is produced in liter. That means there is a relationship between mass and volume. There is a relationship. You have to now do it in unitary method. This one. What you need to do? You have to first find the atomic weight of zinc. Alright, you need to find the atomic weight of zinc. So let us say atomic weight of zinc is 65. So 65 gram gives, let us say 22.4 liter of hydrogen. Okay, when you balance the equation, you will get it Zn plus H2SO4 gives ZnSO4 plus H2. So H2 means 1, that is nothing but what? That is one molecule, which is otherwise known as 1 mole. You will come to know later on. So 1 molecule or 1 mole, what is the volume? I told you already, 22.4 liter, which is known as the molar volume of the gas at STP, 22.4 liter. So hence, 65 gram of zinc gives 22.4 liter of hydrogen. What I asked you, 5 gram, how much it will give? 5 gram will give 22.4 by 65 into 5. So here you need to know the relationship between weight and volume. The sentence which I said you, we come to know. How do we come to know this particular relationship? By looking at the sentence, we derive it. We understand it. That yes, zinc means one what you can say, atom of zinc. So what is the atomic weight of zinc? It is 65 gram. How much hydrogen we are getting it? 1 molecule. So what is the volume? 22.4 liter. So 65 gram is 22.4 liter. So 5 gram will give you how much? Similarly, I may ask you also that tell me that 5 gram of zinc requires how much of weight of sulfuric acid? How much sulfuric acid requires? So this is a relationship between weight and weight, because I have given you the mass of zinc and I am asking you the mass of sulfuric acid. So there is a relationship between mass and mass. In the previous case, what we did the relationship between mass and volume. So how will you find sulfuric acid? Same thing, you find the molecular weight of sulfuric acid, it is 98. So 65 gram of zinc requires 98 gram of sulfuric acid. Write it down, students. All these things you write in your copy. If you just simply listen to the video, you will not understand. It is a time to write now. 65 gram of zinc will give you 98 gram of sulfuric 65 gram of zinc requires 98 gram of sulfuric acid. 5 gram requires how much? 98 by 65 into 5. Unitary method. In this way you can calculate. So here there is a relationship. Now which particular unit? Now see, here we are having a relationship between mass and volume. We are having a relationship between mass and mass. It can be volume and volume. It can be number of atoms and mass. Anything. So you need a unit, a particular unit, a standard unit, which will establish the relationship between all these, between mass and mass, between mass and volume, between volume and volume, between mass and atoms. So that unit, that standard unit is known as what? Mole. So hence I said you, that is, mole is a chemist unit of counting, that is particles. For that reason I said you. So remember that mole is that standard unit which establishes a relationship between mass, volume, atoms, what you can say, anything we can say that. It establishes a relationship. Got it? Because when you are doing the mole concept questions, you will see that when you are doing the mole concept question, you will be getting an equation. Now in that equation, zinc is in the form of solid, sulfuric acid is in the form of liquid, zinc sulfate you got is solid, and hydrogen is a gas. So in one particular equation you can see solid is there, liquid is there, gas is there. In our day-to-day life, are we having this sort of thing? Are we dealing with? No, but in chemistry we deal with. So for that reason we require a unit, a standard unit which will establish the relationship between them, and that standard unit is known as mole. For that reason mole is required, because mole will establish the relationship between that. You can see in the bottom I can given you a particular chart, mind map I have given you to understand about the mole in short. Did you get the idea of mole now? Alright, what is mole? It is nothing but a unit, a standard unit. We can say that. Now we'll come to the definition which I have given you. Now this definition I have learnt in the lower classes also. A mole is that amount of the substance which contains as many elementary entities as there are atoms in exactly 12 gram of carbon, 12 isotope, C2, 12 isotope. The elementary entities must be specified, that is whether they are atoms, molecules, ions, electrons, or any other entity. So we are going to compare these elementary entities, that is atoms, molecules, ions, with the known what you can say entities of carbon. That is carbon we take it because I said you that carbon is the most stable isotope. Got it? That is C12 isotope because it can be stored easily. It does not get deactivated. It is generally available in the pure state. It is readily available, and so many other things are there. Got it? So hence you use carbon, we can say that. Clear? So when we compare with the number of atoms and number of molecules or number of ions or the volume of the carbon or the mass of the carbon with the unknown one which we have to find, then we get the moles. So let us come to the formula first. So in your notes you can see I have given you the definition of moles in 3 ways. I have given you in terms of volume, I have given you in terms of number, and I have given you in terms of weight. I have given you. Got it? The definition of mole. You can see in terms of, that is volume. What is the definition of mole in terms of volume? In case of gases, a mole is defined as that amount of the gas which has volume of 22.4 liter at STP. Very simple it is. I said you 1 molar volume is how much? 22.4 liter of gas. So 1 mole of any gas, remember that's gas. It is gas. You will say, sir, 1 mole of water. Water is not a gas. But if it's water vapor, then it's a gas. So don't say that particular thing. You will say 1 mole of sodium chloride is 22.4 liter. No, sodium chloride is a gas. No. So when you think logically. Understood? So it is for gas only, 22.4 liter or 22.4 decimeter cube, because remember that 1 liter is 1 decimeter cube. Okay? Or it can be also 22,400 ml or 22,400 cc, because 1 liter is 1000 cc and 1 ml is 1 cc. Anything it can be. It depends upon how the question is given to you, whether it's given in terms of liter or decimeter cube or in cc. Cc means centimeter cube, or it's given in ml. So remember it, 1 ml is 1 cc. Please write down. 1 liter is 1 decimeter cube. So 22.4 liter is equal to 22.4 decimeter cube. 22,400 ml. How do we get it? Because 1 liter is 1000 ml. You multiply 1000, 22.4 into 1000. How much you will get? 22,400 ml or 20,400 cc. So 1 mole of any gas at STP occupies this much. 22.4 liter or 22.4 decimeter cube or 22,400 ml or 22,400 cc. In terms of volume, this is nothing but 1 mole of any gas. Mole is represented by small letter n. See that I have given you. Next, in terms of number, how much is 1 mole? In terms of number, what is the definition I have given? A mole is defined as that amount of the substance which contains Avogadro's number of atoms. Avogadro's number is 6.023 or 6.022 into 10 to the power 23. Atoms if the substance is atomic, or molecule if the substance is molecular, or ions if the substance is ionic, anything. So hence I have given you in terms of number, you can see 6.023 10 to the power 23 atoms or ions or molecules, in whatever way the question is given. If the question is given in the form of elements, then it will be atom. If it is given in the form of compound or molecules, it will be molecules. 6.023 10 to the 23 molecules. And if it is given in the form of ions, like Na plus ions, Cl minus ions, then how much is 1 mole? 6.023 10 to the power 23 ions, sodium ions, or 6.023 10 to the power 23 chloride ions. That is known as 1 mole. So in terms of number, remember that 1 mole is this many number of particles. Together we call it as particles. 1 mole is 6.023 10 to the power 23 particles. 1 mole, remember that. Alright, 1 mole is this many particles. 1 mole of molecule, 1 mole of atoms, 1 mole of ion is how much? Avogadro's number. 1 mole. In terms of weight, now weight can be, if it is element, atomic weight. If it is compound or molecules, molecular weight. If it is ionic compound, then formula weight. So atomic weight, 1 mole is how much? Like 12 gram of carbon. See, it is what? 1 mole of carbon. That is a weight of 1 mole of carbon. So atomic weight is nothing but the weight of 1 mole of an element. I have given you the example there. 12 gram of carbon, 23 gram of sodium. What are they? They are the atomic weight of the element. 35.5 gram of chlorine, atomic weight of chlorine. Got it? 16 gram of oxygen is the atomic weight of oxygen. Clear? Similarly, molecular weight, 44 gram of carbon dioxide is nothing but the weight of 1 mole, 1 molecule. Got it? 18 gram of water is the weight of 1 mole. Water is what? Molecule. It is a compound. Got it? So molecular weight is nothing but is equal to 1 mole. Atomic weight is nothing but is equal to 1 mole. Got it? Formula weight. I told you just now to you. 58.5 gram of sodium chloride. That is what? The formula mass. Same as that of molecular mass also. Of is nothing but the 1 mole of sodium chloride. If I ask you what is the weight of 1 mole of sodium chloride? 58.5 gram. If I ask you what is the weight of 1 mole of glucose? Glucose is what? Glucose is what? Glucose is covalent compound. So you find it out. Glucose formula is C6H12O6. So what is the weight of 1 mole? Molecular weight 180 gram. Got it? So it depends upon, if I say sodium, atomic weight, you take the atomic weight as 1 mole. If I take glucose, molecule, compound, you will take the molecular weight. If I take potassium chloride, it's a formula weight, that is 1 mole. So I think it's clear. 1 mole, it's how much? Now let me come to the formula. Thank you. In the next one.